This video will demonstrate how to dynamically adjust the illumination in order to help with complex cases. With the Lumera, we have two different illumination systems, a 6-degree oblique and then a true stereo coaxial lined up with the oculars. So on the left you see the oblique and the coaxial combined, but you can also use coaxial only as needed to enhance the red reflex, and you use this adjustable knob on the side. This is showing both coaxial and oblique, then coaxial only with the enhanced red reflex, and then adding back the oblique when you do the chopping to provide a better illumination of the nucleus. So here again, in this particular case, showing the difference of with and without the oblique component, and now I'm doing the capsulorhexis using only the coaxial light. You'll see that this cuts out the stray reflected illumination from the ocular surface, enhancing the red reflex as we struggle here with the small pupil and the dense anterior cortical spokes that otherwise make it difficult to see the edge of the capsulorhexis. Now what will happen is once we do the hydrodissection and we get to the phaco, we will lose the red reflex, as you'll see here. So I've now added back with that knob the oblique component of the light. So now I'm using both illumination sources because the oblique angle is necessary to give me proper depth perception and to see the contours and shadows as we chop these fragments. So I only use the coaxial only when I'm doing the capsulorhexis or can rely on the red reflex. So as you will see, as we do the phaco, we really don't have a red reflex until finally removing the epinucleus at the end. And that's why the oblique component is important for that phase. Now once we get to the INA, again with a difficult case with weak zonules, I want to see all of the details of the capsule. I can now turn off the oblique and rely purely on the coaxial illumination component to truly enhance the red reflex, as you see here. I've called this the jack-o'-lantern red reflex because it's as though there's a little light source inside the globe, deep inside, creating that illumination. And you'll see here that we can even see little bits of cortex on the posterior capsule. You'll see that in a moment at the very end. And particularly with the small pupil like this, having the enhanced red reflex is truly helpful. Now as I put in the OVD, look at how you can see the little folds on the capsule under a higher zoom here, and how I have to then add a little more OVD, this being dispersive visco, to truly flatten out those folds prior to placing the CTR. And now I have a little occluding shadow from the microscope. Then we go to oblique only, then the coaxial, and then coaxial only, showing all the different settings. Now as I do this, I have to watch the posterior capsule. I see a few striae on the posterior capsule, so I slow down and make sure that there aren't too many, because it is possible to perforate the posterior capsule with the CTR if you catch some of these folds. I keep on the coaxial only as I put in the 3-piece acrylic lens. And even though I have a CTR with the threat of weak zonules, I don't want to leave my capsulorhexis too small. So I'm going to secondarily enlarge it by making an oblique cut and then re-tearing the capsulorhexis out to, but just within the edge of the optic, to decrease further the contractile forces that would normally be opposed by healthy zonules, but in this case with deficient zonules could result in a capsulophimosis. Now as we complete this, I will be removing the iris retractors, and at this point I don't need the coaxial light shining down toward the fundus, so we'll turn that off and use only the oblique. There's the combine, and now I have only the oblique light, so I can still see inside the anterior chamber to remove the retractors, but I've removed the coaxial component illuminating the fundus. And then again we use the occluding element when we put in the atovicral suture to close the sclerotomy. And then when I finally pull this off again, this is the final result. This algorithm of how to dynamically adjust the light was written up in this article in the March '09 Cataract and Refractive Surgery Today.